This is inside, okay? So follow the first part of this video here. And in this situation, g of f of x, as you can tell, g it becomes the outside function, f is the inside function, okay? So now let's look at one more here. Fx is defined here, x squared plus 3. Gx is cosine x, cosine of x. So f of g of x, as we just talked about, h equals cosine square x plus 3. And again, f is the outside function, g of x is inside function, okay? And similarly, if we were asking what is g of f of x, as you can see that it's a cosine of x squared plus 3. And the meaning of the outside function is, if you look at a composite function, this one, this one, this one, this one, it's kind of like what is the big picture, okay, of this function? Because you see, guys, for example, like this, g of f of x, excuse me, overall it's a cosine function, right? Cosine of something, right? It's a cosine something. And this function is a cosine square plus 3. Do you see that the format? It's something square and then add a 3, right? So again, that's what we call it the outside function. And similarly, you have, for here, you have it's something square, right? Something square. I guess for this one, it's not a very straightforward. It's an x squared plus 7. It's a planet. Although this is a composite function g of fx, but you can see that this is a regular polynomial with order of 2. Okay, so through this example, I hope we can have the ability to identify when we have a composite function, what is outside function, what is inside function. Okay, so now let's do some practice, okay? And also, guys, starting from this, I would like to see that, okay, maybe let's introduce an intermediate variable. So set u is the inside function, okay? Is an inside function. Let's take a look at it here. Capital F of x, this is a composite function equals sine of x squared plus 3, okay? And what we can rewrite is, well, do you see that outside function, outside, which is, excuse me, which is sine of x, right? Inside function, which is x squared plus 3, okay? X squared plus 3, okay? And based on this, guys, let's actually rewrite this part with this new notation u, okay? Because we said u is an inside function. Then do you see that overall this function can be rewritten as into this format? I know that my inside function is x squared plus 3, so this is gonna be sine of u, okay? And also I know that the u of x, or u, excuse me, u equals x squared plus 3, okay? X squared plus 3. Okay, so you see, guys, why I write it into this? Because this write it into this way is gonna be helpful for us to learn the chain rule. And let me show you what is the meaning of the chain rule, by using this step. You see, guys, what we are focusing on is we would like to know that what is the derivative of capital F with respect to x. Agree? Right? by introducing one intermediate variable, u, and u stands for the inside function of that computed function. In our problem, u equals x squared plus 3. Okay. And I also replace x squared plus 3 with u, and then let capital F equals psi of u. Okay. Basically, I'm making a substitution. Okay. Look at what we have here. Now, right now, f, do you see, is a function of u, right? F is a function of u. So, to figure out this df dx, which is the derivative of f with respect to x, this is the meaning of the chain rule. What you need to do is to figure out what is df du is. Because once we substitute here into psi of u, do you see that capital F becomes a function with respect to u? Okay. And then we know that to figure out the derivative of this one, easy stuff. Excuse me. And then I need to multiply du dx. Okay. And the du dx, which is, I'm taking the derivative of this with respect to x. Do you see that equals 2 of x? Excuse me. Let me drink some. Okay. So this actually is the core idea of chain rule, which you set u equals the inside function, and then to do those two steps. Okay. First of all, let's take a look at this. df du, again guys, u right now is a variable. Do you agree that it equals cosine of u, right? You know that. And then du dx, do you see it equals to 2x? Okay, equals to 2x. So our df dx gonna be df du times du dx. Okay. Which gonna give us is cosine of u times 2 of x. I'll put a parenthesis here. But guys, this is almost the answer, but not the final answer. Why? Because the derivative of capital F with respect to x, the final answer should only contain one independent variable, which is x only. But look at it here, we still have this u here. But knowing that u equals x squared plus 3, substitute it back. Hence, the final answer for this is going to be cosine of x squared plus 3 times 2x, okay, times 2x. So, congratulations, you just finished your first chain rule problem, okay, so this is a chain rule thing. Okay, so there are actually two ways to interpret this problem, for the chain rule. One is to think about it, the derivative of this is the derivative of the outside function with respect to the inside function, which basically, guys, you consider this sine of x is one whole piece. So the derivative of the outside function with respect to the inside function, which give us is a cosine of x squared plus 3. And then multiply the derivative of the inside function, which is 2x. That's the first way to explain the chain rule. It uses the outside function, inside function. The second way to interpret the chain rule, which is the way I just talked about, I set a u equals the inside function, and then I make the substitution with my function into this, and knowing that the derivative, so df dx equals df du times du dx. So this part and this part very easy to handle. And then you got this, you substitute u back with x squared plus 3, and then you still can get the answer. I realized that the second way to talk about chain rule probably is the good start for for the students if you have not touched this chain rule concept. After you do some practice for the chain rule problems, I'm pretty confident that you know you're gonna know what is spirit of chain rule, and sometimes, or you know, you might just skip all of this and directly write to the result. Okay, but that is you have to do a lot of practice. Okay, before you can do that. So okay, so this is the first one. Now let's talk about the second one. Okay, this one. Fx equals 7x squared plus 1 cubed. Let's use the other one. 7x squared. Okay. So let's see. 7x squared plus 1 the cube. Okay. So let's look at this. Well, as you can see, the outside function, which is x squared, x cubed, right? Inside function is 7x squared plus 1. But again, let's do this. Set u equals my inside function, which is 7x squared plus 1. The capital F I set as u cube. Okay, u cube. Since df dx equals df du times du dx, so I need to handle those two. So first of all, with du dx, which is the derivative of this with respect to x, which gives us is 14x. And then df du, which gives us the 3u squared, right? And then we can make the substitution, which gives us is the 3u squared times 14x. Again, our final answer should only contain the variable x. And so I substitute u back with 7x squared plus 1, so that gives us 3 times 7x squared plus 1 squared times 14x, and that is the final answer. Okay, guys? So, right, find the inside function, make the substitution, and then figure out du dx, df du, multiply, substitute back, done. Okay, so this is the second one. Now let's look at another problem. Capital F of x, again, equals, let's see, e to the power of sine x, okay? To the power of sine x. And as you can see that, the outside function for this, it's e to the power of x, right? Inside function, which is sine of x. So set the inside function equals sine of x. Then capital F gonna equals e to the power of u. Okay. And again, du dx equals cosine of x. Okay. And the df du, which you're tweaking the derivative of this with respect to u, which we know that it's e to the power of u. Hence, df dx equals df du times du dx, which gives us is e to the power of u times cosine of x. And then we substitute u back with sine of x. So that is e of sine of x times cosine of x. Okay. So, all right. So these are the two other chain rule problem. As you can see, guys, you know, I'm pretty sure at this stage you should be like familiar about this u substitution technique. But let's also think about it, the interpretation of the other way for chain rule. That is, if we are taking the derivative of this with respect to x, like this, So I have to take the derivative of the outside function with respect to the inside function, okay? So first, that is, I'm taking the derivative of this, but considering this as a variable for the first stage. So that is the derivative of the outside function with respect to the inside function, which is gonna be e to the power sine of x, okay? And then times the derivative of the inside function, which is cosine of x, okay? Cosine of x. So yeah, now let's see what kind of questions we have. So now let's look at this one here. Let me erase this. So as you can see, like this, we're looking for this one. So u gonna be x squared plus 20x, right? The inside function. Capital F gonna becomes a function of u, which is tan of u. Okay, tan of u. And then we're starting to do what is du dx, which equals 2x plus 20. What is df du? We learned this from 3.5, which is secant square of u, right? And so df dx equals df du times du dx, which give us is secant square of u times 2x plus 20. But again, I have to substitute u back with x squared plus 20x. So it's a secant square of x squared plus 20x. And then, maybe use a bracket, multiply 2x plus 20. Okay, so now we're done for this, okay? So this is the second part of the chain rule. And I'm gonna have the third part, and I'm gonna show you a little bit more, comprehensive examples, so you can master chain rule. Okay, so I'll see you in a minute.